Okay, hello everyone. So today I will have a quick lecture about kinematics. So we will identify the fundamental quantities of kinematics, relate these quantities to each other mathematically, and connect these quantities to understanding real-life situations. So first, let me begin by watching a video about Top Gear.
Over there is downtown Abu Dhabi. Between me and it is a 4-mile arrow straight stretch of highway. And it's closed. How lucky is that?
Oh, what a noise!
140, 150, 160, 170 miles an hour. Whoa! You just met the Lamborghini Murcielago LP670-4 SV. Or to put it in plain English, the fastest Lamborghini ever made.
Okay, so in that video, we saw a Lamborghini Murcielago go down a highway in Abu Dhabi in a very straight path. It's 4 miles long, and it completed it in, let's say, 1 minute 30 seconds. So let's just ask a few questions. So the car that was involved in the video was a Lamborghini Murcielago. It traveled a 4-mile straight highway in around 1 minute 30 seconds because that's around the length of the video. The top speed, if you were very observant, was that the car actually hit 200 miles per hour. And a 0 to 60 time of the Lamborghini Murcielago, if you are very geeky with your cars, I did some research, it's 3.2 seconds. So that actually means that a car can accelerate from 0 mph to 60 miles an hour in just 3.2 seconds. Okay, so that was the statistics or the specifications of the run of that Lamborghini. Now let's focus on the length, 4 miles straight highway. So what do you call a quantity that is described by the length? It starts with the letter D. It's actually called distance and displacement. So distance is the scalar quantity and displacement is the vector quantity. So in this case, 4 miles straight highway, the distance would be just 4 miles because distance as a scalar quantity would just be the value. Displacement, meanwhile, because it has direction, would be 4 miles going straight. Now, let's have an example. So let's go to our vector addition example. Let's say you have two vectors over here, 8 meters and 6 meters. So initially you go up with the 8 meters, and then you go to the right with the 6 meters. Okay? So when you're asked for the total distance traveled, what does it mean by that? Total distance. Well, if it's distance, you're basically going to add the path that you traveled. So the path that you traveled is this way, 8 meters, and then this way, 6 meters. So that will be 8 plus 6. That will give you 14 meters. But what if you're asked, what is the total displacement? Well, what's the root word of displacement? If you look at it closely, displacement. Displace. How much were you actually displaced from your original position? So your original placement is around here. You were displaced to go in this direction. So how far is that? What's the total displacement? It is 10 meters, which is the resultant. And because it has a direction, this one goes northeast. Because if you were to draw the compass, it goes in between north and east. But I have a question. So what is the total displacement if you go back to where you started? So let's say I have a guy here. He walks that way, and then after a while, he then walks backwards to where he started. What is the total displacement in that entire sequence? So I'll give you a few seconds to think. Pause the video for a while. Okay, so again, the root word, displaced. The question is, if you go back to where you started, were you really displaced? Well, the answer there is no, because you're back to the same position. You were not displaced at all. And if you look closely, you're adding a positive vector with a negative vector of the same value. So if it's the same value, the result will always be 0. Okay? So that's for displacement. Now what about this one? Length and time. When you have length and time, what quantity can you obtain? Well, we know a few quantities that involve length and time. So an example of a quantity involving length would be meters. Another example involving time would be seconds. And you know meters per second. This is an example of a quantity of speed or velocity. So speed and velocity, speed is your scalar quantity and velocity is your vector quantity. So how do you get the average speed and velocity given this run? Well, we can use this simple triangle here that goes, the D is on top and the bottom is V and T. So if you were to cover the V, it's just D over T. Same with all of the other aspects. If you want to get distance, velocity times time. If you want to get time, distance over velocity. Okay? Or displacement rather, because it's a vector. So to get the average speed and velocity, it's D over T. So average speed is distance over time. Average velocity, because by definition it's the change of position. Remember, this means delta, which is change. Okay? Velocity as a vector quantity would be displacement over time. So if we were to calculate the displacement over time, or rather the average speed of the Lamborghini in miles per hour, so first we convert the time into hours. So how do we do that? So 1 minute can actually be converted to 1.5 minutes or 1.5 minutes. Now, how do we convert that to hours? Well, we know that in 1 hour you have 60 minutes. If you multiply this, that cancels out. 1.5 over 60 will get you around 0.025 hours. Okay? And if we were to divide 4 miles of highway by 0.025 hours, we would get somewhere around 160 miles per hour. Just imagine how fast that is, because in the NLEX SLEX, our speed limit is 100 kph. That's around 60 miles per hour or 70 miles per hour. Here, 160 miles per hour is more than twice that speed. That is pretty damn fast. Now, let's go back to the video. What was the top speed of the Lamborghini? Well, I actually took a screenshot of that. So here, as you could see, it's somewhere around 200. And what do you call the speed that an object is experiencing at that very instant? So at that very instant. So from that statement alone, instant, it's called instantaneous speed. So let's say that my pointer over here is actually at 40. That means the instantaneous speed would be 40 miles per hour. But since it's at 200, it's 200 miles per hour. Now, let's go to the other one, the 0 to 60 time. So in car specs or in racing, 0 to 60 is how fast a car can go from rest, or 0, to 60 miles per hour, or around 100 kilometers per hour. The Lamborghini can do it in just 3.2 seconds. So imagine that. You can go from stop to the maximum speed of the highways in the Philippines in just 3 seconds. That's pretty fast. What is the measure of how fast something hits a certain speed, or how fast something changes the rate at which it travels? It's called acceleration. So acceleration is a vector quantity. Why? Because it is either positive or negative. So it has direction. Okay, so how do we get the average acceleration given these values? Well, average acceleration is defined as the change of velocity over time Or if it's changed, that means it's always final minus initial. Remember, if you see a change of velocity, most of the time you're comparing final minus initial. And since acceleration is delta v over t, the units would be velocity units per time unit. So an example of a velocity unit, meters per second. Okay, an example of a time unit would be second. If you were to divide that, you would get meters per second squared. It's essentially meters per second per second. Now, how do we calculate the acceleration of this Lamborghini? So using miles per hour squared, remember I could use any time unit here. So 0 to 60. So again, Vf is equal to Vf minus Vi over t is equal to acceleration. What's your Vf? Vf is the final velocity, or 60. Vi is your initial velocity, or 0. So we'll just put it like that. And your time, 3.2 seconds, or I already converted it to hours, 0.00089 hours. And if you were to divide that, this is miles per hour, by the way, you would actually get a very high value of around 70,000 miles per hour squared. It's pretty high, I'm going to say that. But if you were to convert this, sorry, I skipped a lot of things there. But if you were to convert that to something like meters per second, so if you convert miles to meters and hours squared to seconds squared, then you would get a reasonable value of around just 2 digits. Okay? So that is how fast your Lamborghini can actually accelerate. Now, let's talk about the direction of acceleration. So in this scenario over here, the red car is actually traveling at a constant speed. Okay? It travels at a constant speed, and this means that if it's a constant speed, does the change of velocity at the top change? Well, if it's constant, velocity does not change. If it does not change, then this thing on top would just be 0. Okay? That means that 0 over t would just give you a value of 0. So constant speed means 0 acceleration. What about if you're slowing down? Well, if you're slowing down, that means that your final velocity will be less than your initial velocity because you're slower than when you started. If final is less than initial, then if you were to subtract Vf minus Vi, you would get somewhere around the negative because Vi is actually bigger. Okay? So if that's negative, negative number over t would get you a negative acceleration. Now, what about speeding up? So when you're speeding up, you have Vf is actually greater than Vi. So when you do Vf minus Vi, that means that this will be positive. And if it's positive over t, that means speeding up is a positive acceleration. Now, here's a question. Can a car move opposite to its acceleration? Please think about that for a moment. Now, here's an example. So let's say this car over here is moving in a positive direction. But remember, it's actually slowing down. So when it's slowing down, that means it has a negative acceleration. So here, positive direction, negative acceleration, because it's hitting the brakes. So that means that you can actually move opposite to your acceleration. Okay? So I hope that my video enlightened you on the concepts of the fundamental quantities of kinematics, and I wish you luck for our quiz and our long test in a few hours' time. So all the best and take care.